morning to everyone. We are dealing with the chapter motion and laws of motion. In this chapter, we have studied about Newton's first law of motion, Newton's second law of motion and Newton's third law of motion also, isn't it? So today we are going to move to the next topic. The name of our topic is law of conservation of momentum. I think it's a new topic for you, isn't it? So look at here. Consider two bodies, that is A and another body, that is B. Okay, here A and B are two bodies with masses. Okay, here M1 is the mass of A and M2 is the mass of B. Okay, is it clear? Here M1 is the mass of A and M2 is the mass of B. Okay, here M1 and M2 moving with a initial velocity. Here M1 and M2 are moving with an initial velocity, that is U1. Okay, and M2 is moving with an initial velocity, that is U2. Is it clear? Once again, here M1 is moving with a velocity, initial velocity, that is U1, and M2 is moving with an initial velocity, that is what? U2. Okay, after they collide each other, their velocity changes. So this takes place before collision. Okay, before collision. Okay, when they collide each other, their velocity becomes changed. So consider two bodies, that is A and B. Okay, here also mass M1 and M2. Here also two masses, that is M1 and M2. When they collide each other, their velocity changes to V1 and V2. Is it clear? When they collide each other, their velocity changes to V1 and V2. Okay, after collision. Is it clear? So, after collision, here what happened is their masses are same. Their velocity may change to V1 to V1 and V2. Once again, when collision takes place, their masses become same and their velocity changed to V1 and V2. Is it clear? Then already we have studied about momentum. Okay, how can you find momentum? Momentum is equal to mass into velocity. The product of mass into velocity is known as what? Momentum. Is it clear? That we have studied in the last class. Now what we are going to do is we are going to find the momentum of both A and B separately. We are going to find the momentum of both A and B separately. Here what we are going to do is, first we are going to find the momentum of A and then we are going to find the momentum of B. Okay, first one, the initial momentum of A. Initial momentum of A. Okay, I am representing momentum by using the symbol P. Okay, here the initial momentum of A is M1 U1. Okay, is it clear? M1 U1. Is it clear? After collision, what happened to it? What happened to it? The velocity changes. Okay, then the final momentum of A is what? The final momentum of A is M1 V1. Is it clear? M1 V1. Then we want to find the change of momentum. How can you find the change of momentum? That we have studied earlier, that is MV minus MU. That is final momentum minus initial momentum. Okay. Then change of momentum. Change of momentum, that is m1 v1 minus m1 u1. Is it clear? Next we want to find is rate of change of momentum. Rate of change of momentum. Okay, the rate of change of momentum is m1 v1 minus m1 u1 by t. Okay, we can write the rate of change of momentum is equal to m1 v1 minus m1 u1 by t. Okay, next we want to find is the momentum of B. Okay, next we are going to find is the momentum of B. So first one, the initial momentum of B is what? Initial momentum of B. The initial momentum of B is m2 u2. Okay, the initial momentum of B is m2 u2. Okay, then next one, final momentum of B is what? That is final momentum of B. Final momentum of B is m2 v2. Is it clear? Is it clear? Then we want to find next is change of momentum. Then change of momentum is what? How can we write? The change of momentum can be found out by, the change of momentum can be seen by final momentum minus initial momentum. Okay, that's equal to m2 v2 minus m2 u2. Is it clear? Is it clear? Then next we want to find is rate of change of momentum. Rate of change of momentum. Rate of change of momentum. How can we write that? That's equal to m2 v2 minus m2 u2 by t. Is it clear? Then according to Newton's second law of motion, the rate of change of momentum is directly proportional to the unbalanced external force. So we can write as FAB equal to what? m1 v1 minus m2 u2 by t. Is it clear? Here FAB means the force applied on B on A. The force applied B on A, that is equal to m1 v1 is equal to m2 u2 by t. That means the rate of change of momentum is directly proportional to the unbalanced external force. Okay, then as in the case of B, the momentum B, we can write as FBA, that is the force applied A on B, that is equal to m2 v2 minus m2 u2 by t. Is it clear? Why we have written like this? Because the rate of change of momentum is directly proportional to the unbalanced external force. Okay, that's why we have written in terms of FAB and FBA. Is it clear? Then according to Newton's third law of motion, for every action there is equal and opposite reaction. Is it clear? That you have studied in the last class. For every action there is equal and opposite reaction. Okay, so here the force exerted by A on B is equal to the force exerted by B on A. Okay, so there is action and reaction takes place here. So we can write as there will be action in different directions. Okay, so we can write FAB equal to minus FBA. Okay, this we studied in the last class. Okay, so we can write m1 v1 minus m1 u1 by t equal to minus m2 v2 minus m2 u2 by t. Okay. m1 v1 minus m1 u1 by t equal to minus m2 v2 minus m2 u2 by t. Okay, is it clear? So t will be cancelled. Okay, then it becomes m1 v1 minus m1 u1, that's equal to minus, you can put this in the bracket, m2 v2, it becomes plus m2 u2. Is it clear? m1 v1 minus m1 u1 is equal to minus of m2 v2 plus m2 u2. Is it clear? We can bring these u terms and v terms together. Okay, so we can write m1 v1, okay, plus we can bring this m2 v2 here, it become plus m2 v2, that's equal to, okay, that's equal to m1 u1 plus m2 u2. Okay, when here minus sign, then it become plus. Okay, so we can say final momentum is equal to initial momentum. Is it clear? So total momentum before collision is equal to total momentum after collision. We can conclude from this is total momentum before collision is equal to total momentum after collision. Okay, is it clear? So we are going to state the law of conservation of momentum. Look at here. In the absence of an external force, the total momentum of a system is constant. Okay, the law of conservation of momentum states that in the absence of an external force, the total momentum of a system is constant. Okay, so this is all about today's class. I think all of you got cleared. Thank you.